Welcome back. Today's goal of this lecture. Today, I will see some example based on countable set and uncountable set. In my previous video, I had discussed this type of question. Today, I will see some question which I had not discussed in my previous video. But at first I will highly recommend you, please see my previous video. If you don't see my previous video, then today's video you cannot understand in better way. And I have given the link in description box. First question, which I will define at first. This is the question. This question which I had defined previous video. Then next part I will define today's video. Okay. So at first see my previous video. Let's see the first question. In my previous video I had defined these two questions. Today I will define the set of 2 cross 2 real matrices with rational eigenvalue and set of all real matrices whose row equivalent form has rational entries. Is countable or uncountable? At first I will see set of all 2 cross 2 real matrices with rational eigenvalue. Is it? At first I will see set of all 2 cross 2 real matrices with rational eigenvalue. Is it countable? For A be the set of all 2 cross 2 real matrices with rational eigenvalue. Notice here 2 cross 2 real matrices, but the eigenvalues are rational. So consider S equal to those type of upper triangular matrices alpha, beta, 0, R, where R be the member of R. Since this is the upper triangular matrices, so we all of us know diagonal entries are eigenvalue of upper triangular matrices, where alpha beta be the fixed rational number. That means alpha beta are rational eigenvalue of each matrices S, where S be the upper triangular matrices. And A be the set of all 2 cross 2 matrix with rational eigenvalue. Obviously, these S contain A, since A is the upper triangular matrix. And S is the set of all upper triangular matrix and A be the not only all upper triangular matrix, S is the set of all 2 cross 2 upper triangular matrix and A be the set of those 2 cross 2 real matrices whose eigenvalue be the rational. Since S contain A, and what is the cardinality of S? Since this type of matrix depends on this value R, where R be the real number, so obviously cardinality of S is quantum number C. Since for each value of R I will get different type of upper triangular matrix. So and R be the member of real number, so cardinality of S is quantum number C, continuum number C. So the cardinality of S is continuum number C. And since S be the subset of A, where A is the 2 cross 2 real matrix with rational eigenvalue, so obviously the cardinality of A would be continuum number C. I hope my all viewers have understood this is okay. Next I will see the set of all real matrices whose row equivalent form has rational entries. Is it true option? Let A be set of all real matrices whose row equivalent form has rational entries. That means S contains those matrices A, 2A where a belongs to real number and a not equal to 0. After row reducing, at first R1 divided by 1 over a R1 and R2 divided by 1 over a R2, then the matrices reduces 1 1 1 2. Then R2 equal to R2 minus 2 R1, then these matrices would be reduced as 1 1 0 1. And this is the row equivalent from with rational entries. But since here S depends on those value of A where A belongs to real number and A not equal to 0, then the cardinality of the set S is quantum number C, and since S contain capital A and since cardinality of S is quantum number C, so obviously cardinality of A is uncountable, because A is set of all real matrices whose row equivalent from has the rational entries. Okay. I have considered this particular type of S, that means since S is contain A and since S is uncountable, so obviously A is uncountable. That means fourth option also wrong option. I hope my all viewers have understood this type of question clearly. Next question. P equal to set of all polynomial with rational coefficient, that means P equal to a0 plus a1x plus a2x square up to so on, where I equal to 0 1 2 so on, where a0 belongs to Q, a1 also belongs to Q, a2 belongs to Q up to so on. That means P equal to Q cross Q cross Q. This is n minus 1 times. Therefore, means P equal to finite product of n equal to 0 to n plus 1 Q cross Q cross Q. And in my previous video I had seen finite product of countable set is countable. This type of question I had discussed in my previous video. So S is countable. P is countable, and S denoted the set of all sequences of natural number. Is it countable set? Here S be the set of all sequence of natural number. Since S be the set of all sequence of natural number, that means S equal to those an such that an be a function from n to n. Therefore, cardinality is alif naught to the power alif naught, and alif naught to the power alif naught means this is nothing but this is actually quantum number C. That means set of all sequence of natural number which is defined from natural number to natural number, means we all of us know sequence always defines from natural number to natural number, and obviously this is be a function, sequence be a function. This type of set contain uncountable number. So P is countable and S is uncountable. Now let's see the option. First option denoted S is countable. This is wrong. Second, both P and S uncountable. This is also wrong. Third, both P and S are countable. This is also wrong. And fourth, P is countable but S is not. This is right option. I hope my all viewers have clearly understood this part. Okay. Next, which of the following sets is countable? Option 1. Set of all function from Q to Q. We all of us know this is alif naught to the power alif naught, and alif naught to the power alif naught always quantum number C. So this is uncountable. So this option is a wrong option. The set of all function from Q to 0 1. This is 2 to the power alif naught, and 2 to the power alif naught is nothing but this is also quantum number C. So this also wrong option. Set of all subset of natural number, this is denoted as power set of natural number, and power set of natural number means 2 to the power alif naught, and this is equal to actually quantum number C. So this is also wrong option, because the option is which of the following set is countable. And option 3, the set of all function q2 01, this is also 2 to the power alif naught which vanishes outside a finite set. That means if A equal to finite set, that means f of A equal to 0 when x not belongs to A, and 1 when x belongs to A. And since A is a finite set, that means obviously countable. And third option, the set of those function which vanishes outside of the finite set, that means this type of function, and this is actually union of n equal to 1 to infinity f of A, and we all of us know countable union of countable set is always countable. So this is right option. The set of all function q2 01 which vanishes outside a finite set. This is always right option. I hope my all viewers have understood this is okay. Example, this is also very easy type but very conceptual. Here capital S be a infinite set. That means capital S can be countable or uncountable. Because infinite means it may be countable or it may be uncountable. Then which of the following statement are true? Option 1. If there is an injection from S to natural number, then S is countable. Is it possible? At first, just recall, when there is a map from S to natural number, if this is 1-1 map, then always cardinality of S would be less than equal to cardinality of natural number. This is the rules of injection. When there is a injective map from S to natural number, that means cardinality of S always would be less than cardinality of natural number. And here the cardinality of n is alif naught. Here given, if there is injection, then S is countable. Since this is countable, and we all of us know any subset of countable set is countable, so obviously S is countable. I hope my all viewers have understood. So option 1 is a right option. Option 2. If there is a surjection from S to natural number, then S is countable. If there is a onto map from S to natural number, then always cardinality of S would be greater than equal to cardinality of natural number. So, since cardinality of S greater than equal to cardinality of natural number, so it may be countable or uncountable. So this type of onto map may be exist or not exist. This is should be exist. This we cannot tell. Then it may be uncountable. For uncountable, we cannot tell if there is a surjection from S to natural number, then S is countable. So option 2 is a wrong option. Option 3 imply if there is an injection from n to natural number, here the map, n to S, natural number to S, then S is countable. At first try to answer. 1-1 map means cardinality of n always less than, strictly less than cardinality of S. but cardinality of n is alif not, so S may be similar to before. S is maybe countable or not. So there is an injection from n to s when s is countable. This is not always true. For case of uncountable, there can be exist 1-1 map. I hope my all viewers have understood. So option 3 is a right option. And option 4 indicate is there is a surjection means onto map from natural number to s. That means cardinality of n should be greater than equal to cardinality of s. Since cardinality of natural number is alif not, which is countable, so obviously s would be countable, any subset of natural number. So this option, sorry, this is wrong option. Third option is a wrong. There cannot exist, sorry. But option 4 is a right option. I hope my all viewers have understood. This type of question actually very conceptual but very important for higher study, also for any competitive exam. Question: which of the following statement is true? We said come CSIR NET 2020 exam. The question is there are at most countable many continuous function from R2 to R. Here the function which map from R2 to R. Number of continuous function we all of us know. C to the power C square, because the cardinality of R square is C square. And this value is quantum number C, which there are at most countably many continuous function from R to R. This is not true, because there can be at most uncountable many continuous function from R2 to R. So option 1 is a wrong option. Option 2, there are at most finitely many continuous surjective map from R2 to R. FBA mapping for R2 to R. Is this mapping is surjective? Obviously onto means cardinality of R2 always would be greater than equal to R, cardinality of R, because this is cardinality is C square and this cardinality is C. Cardinality greater than means always it can be possible onto function. This type of onto function, possibility of onto function, uncountable, at most uncountable onto function possible, but in the question has indicated there are at most finitely many. This is not true. So option 2 also not correct. Option 3 imply there are infinitely many continuous injective function from R2 to R. Here the mapping A from R2 to R. 1-1 means always cardinality of R2 would be less than equal to cardinality of R, and this is not true, because here C square and here C. Also, if this is possible for infinitely many, for this case this is not true, because if there exists such type of 1-1 function, then it would be infinitely many not. It would be uncountable number of continuous function, continuous injective function. But obviously this is not possible, because cardinality of R2 and cardinality of when 1-1 function means cardinality of R2 always would be less than cardinality of R. This is not true. Option 4, there are no continuous bijective map from R2 to R. It is true, because A from R2 to R, here cardinality of R2 is C square and cardinality of R is C. Since both cardinality are not same, so this is not possible. There are no continuous function bisective map from R2 to R. This is not possible, because when there exists bisective map exists, because bisective map exists means their cardinality all equal. But since here the cardinality are not same, cardinality of domain and codomain are not same, though, so there cannot exist bisective continuous map. So option 4 is a right option. I hope my all viewers have understood clearly. Okay? Oh well. Today I will stop here. This type of question actually very important for higher study, also for any competitive exam. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.